Welcome back to the deep dive. You know, I was actually walking into my office building this morning and
Just a normal morning.
yeah, exactly. I grabbed my coffee, took the elevator up to the 10th floor, sat down at my desk, and it just hit me.
What did?
I realized I didn't think once, not even for a split second, about whether the floor would actually hold my weight or if the building was suddenly going to catch fire. We just completely take it for granted. It's this concept of invisible safety.
Right. We just assume we're safe.
Exactly.
And honestly, that is the ultimate goal of good engineering. When it works perfectly, it's completely invisible to you. You essentially outsource that worry to total strangers.
Right, to the architects, the engineers, the inspectors.
Yeah, but when you step into the industrial world, into a factory setting, that casual assumption just isn't enough anymore. In that kind of environment, safety isn't just a default setting. It is a incredibly rigorous, complex engineering challenge.
I can imagine. And today, we're going to look at what happens when that trust actually has to be codified. We're doing a deep dive into the sheer bureaucracy and the hardcore engineering that stands between a functioning factory and an absolute disaster.
Oh, yeah.
We're looking at the Fire No Objection Certificate, or the Fire NOC, and safety audits for factories over in India.
And I am so glad we're doing this because, look, let's be honest. To the uninitiated, no objection certificate sounds like, well, it sounds like the dullest piece of paper imaginable.
Ah, yeah, it really does.
It sounds like a permission slip. You just get to make some local government official go away.
Which is exactly what I thought when I first saw the topic.
Yeah.
But then I started looking at the source stack you brought in for us today.
It's dense.
Very. We've got these technical guides on the Guide to Fire Safety Audits. We have the massive National Building Code of India, the NBC, and this absolute alphabet soup of Bureau of Indian Standard specifications.
Yep.
This is clearly not just paperwork, is it?
Far from it. This is practically a survival manual. And our mission today is to decode that manual for you. We want to get past the government stamps and understand the actual logic of fire safety.
Because there's a real science to it.
Exactly. When you strip away all the acronyms, getting that certificate isn't really about compliance. It is about physics, chemistry, and human psychology all colliding in a very high-stress environment.
I have to admit, digging through these sources, I was pretty surprised by how complex just getting a certificate actually is. I kind of thought, you buy a few red extinguishers, slap up a glowing exit sign, and call it a day.
I really wish it were that simple. But you shouldn't frame this as compliance. Think of it more as proactive risk management.
Okay.
If you own a factory, or even if you just work in one, this entire process is the firewall, sometimes literally, between business continuity and a total catastrophic disaster.
Wow, okay, let's unpack this properly then. First things first, what exactly is the Fire NOC in the eyes of the law?
Simply put, it's a mandatory legal document issued by the state fire department. It certifies that a specific building or facility has met all the minimum requirements for fire prevention and life safety.
So it's the green light.
Essentially, yes. Without it, you cannot legally occupy a factory. You cannot flip the switch on the production line.
And this isn't just a new local city rule, right? This goes back a pretty long way.
It does. The legal bedrock here is the Factories Act of 1948.
Wow, 1948?
Yeah, it's the granddaddy of industrial legislation in India. It mandates that factories absolutely must protect their workers, but the NOC is the actual mechanism that proves you've done it.
Got it.
However, it is not a blanket rule for every single tiny shed out there. The sources are very specific about who actually needs to panic or rather prepare for this.
Right, I saw those numbers in the source material. It seems to function on a sort of trigger system. Let's break those triggers down. Who is on the list?
Think of it as a risk matrix. Trigger number 1 is hazardous substances.
Okay, so the obvious stuff.
Right. If you are handling explosives, chemicals, flammable gases, anything that goes boom, you need an NOC, period.
Regardless of the building size.
Regardless, it doesn't matter if your factory is the size of a one-car garage. If the materials are volatile, the risk is inherently high.
That makes total sense. Now, trigger 2 was height. The magic number in the document seems to be 15 meters.
Right. Roughly 4 to 5 stories tall.
Now, why 15 meters? Is that just an arbitrary cutoff?
Not at all. It wasn't just pulled out of a hat. That 15-meter mark is historically the effective reach of a standard fire department ladder.
Oh, wow.
Yeah, so once a building goes above 15 meters, external rescue becomes exponentially harder. The fire truck ladder literally might not reach you.
So what happens then?
The building has to be designed to save itself.
The building has to save itself. That is a Terrifying, but incredibly helpful perspective.
It really changes how you look at architecture.
Definitely. And the third trigger was area, I think, 500 square meters.
Yes, large covered areas. This is all about what we call the fire load.
Fire load, what does that mean?
Basically, if you have a massive warehouse, even if it's only 1 story tall, the sheer volume of combustible material inside cardboard, plastic wraps, wooden pallets, it creates a fire intensity that requires highly specialized suppression systems.
So a standard handheld extinguisher just won't cut it.
Not a chance. You need the heavy artillery.
Okay, so if I'm running a massive warehouse or a multi-story production plant, I am definitely on the list. But here is where it gets really interesting to me. The sources talk about the Bible of Safety, the NBC.
Ah, yes. The National Building Code of India 2016, specifically Part 4.
Part 4.
Yeah, if you are in the business of building anything in India, Part 4, fire and life safety is your absolute scripture.
And inside this code, they classify buildings, right? It's not just a binary factory or not factory. They have this Group G classification.
Right. Industrial buildings as a whole fall under Group G, but the code recognizes that a factory making, say, ceramic tiles poses a vastly different risk than a factory making fireworks. So they break Group G down into hazard levels, G1, G2, and G3.
Help me visualize these. What does a G1 actually look like?
G1 is your low hazard. Think of a brick kiln or a metal fabrication shop where you are basically just welding heavy steel parts together.
So the stuff inside doesn't really burn.
Exactly. The building contents themselves have very low combustibility. You would have to try really, really hard to burn a brick factory down. So the requirements there are pretty minimal.
Okay. And G2?
Moderate hazard. This is where most standard manufacturing is going to fall. Textile units, assembly lines for electronics, food processing plants.
So there's fuel to burn.
Right. There is fuel, cardboard boxes, plastic casings, fabric, but it's manageable with standard systems.
And then we have G3.
High hazard. This is the truly scary stuff. Chemical plants, oil refineries, distilleries, places where the air itself can literally become flammable. The requirements for a G3 facility are drastically higher. You aren't just putting up illuminated exit signs. You are looking at blast-proof walls, foam suppression systems instead of water, and extremely strict ventilation controls. It is a completely different world of engineering.
Okay, so the NBC tells us what category we are in. But looking at these sources, the NBC didn't seem to tell me exactly which screw to use on the fire extinguisher or how thick the water pipe needs to be.
No, it doesn't. For that level of granular detail, we need the code breakers. We need the Bureau of Indian Standards, or the BIS.
Yeah, this was the part of the reading that genuinely felt like learning a new language.
Yeah.
IS 1641, IS 2190.
Yeah.
I mean, it sounded like droids from Star Wars.
It really does a bit. But think of the BIS standards as the technical how-to guides. The NBC says, broadly, you need a fire extinguisher.
Right.
The BIS standard, specifically IS 2190 in this case, tells you, for a Class A fire, you need a water CO2 type. It needs to be placed exactly here, and it must be maintained in this highly specific way.
Let's pick a few of these apart, because I think the detail is where the real insight is for you listening. IS 1641 really caught my eye. It covers fire grading.
This is a totally crucial standard. IS 1641 basically asks, if this room catches fire, how long will the walls actually stand up?
Oh, interesting.
Yeah, it rates structural elements in hours. So a 2-hour fire rating means that specific wall is engineered to hold back a raging inferno for exactly 120 minutes before it either collapses or lets the fire pass through.
Which basically just buys you time.
Exactly, and time is the only currency that matters in a fire.
That makes total sense.
Then you have IS 2190, which we just mentioned. It's not just about going to the store and buying any red extinguisher, it is about chemistry.
Right, because different fires need different reactions.
Exactly. You absolutely cannot put a water extinguisher on an electrical fire.
Because water conducts electricity.
Right. You will electrocute the operator. And you can't use a standard foam extinguisher on a metal fire. IS 2190 is designed to prevent you from making a split-second mistake that turns a small, manageable fire into a fatal tragedy.
And what about IS 15105?
That one covers sprinkler systems. It dictates everything: the water pressure, the exact spacing of the sprinkler heads on the ceiling, the pipe diameter.
So it's very exact.
It has to be. If you get the math even slightly wrong on that pipe diameter, you might just get a pathetic trickle of water when you desperately need a deluge.
It's amazing how specific it gets. There's zero subjectivity here.
None at all. And here is the real connection to the physical world. State services like the Uttar Pradesh Fire Prevention and Fire Safety Act of 2005, which popped up in our source stack, they use these national standards to actually enforce local rules.
So if you're setting up shop in Agra or Lucknow, the local law effectively just says, hey, go do what the BIS says.
Exactly, and the consequences are very real. We aren't just talking about a bureaucratic slap on the wrist here.
Right, this isn't a parking ticket.
No. Non-compliance leads to heavy fines, total factory shutdowns, and under the new Bharatiya Nyaya Sanhita, you could face serious legal action for negligence.
Criminal negligence?
Exactly. If you actively ignore these codes and someone gets hurt, that isn't just viewed as an accident anymore. That is criminal negligence.
That puts a really heavy weight on this whole process. So let's say I'm an entrepreneur. I've got my capital together. I have my big idea, and I want to build a factory, and I want to do it right. Walk me through the actual life cycle of getting this NOC. When does it even start?
Well, if you wait until the building is built to start thinking about fire safety, you have already failed.
Oh, really?
Yes. The life cycle starts at step 1, pre-construction clearance.
So I have to show them my homework before I even lay a single brick.
You do. You have to submit 3 full sets of plans, the site plan, the floor plan, the elevation, directly to the chief fire officer.
And I'm guessing I can't just sketch these out on a napkin.
Definitely not. They must be strictly certified by a licensed fire consultant or an architect. The fire department is checking the very DNA of the building.
What kind of things are they looking for on paper?
Are the staircases wide enough? Is there an accessible perimeter road around the building so a fire truck can actually circle it?
Right, because if you get that wrong in the concrete phase, you can't exactly move a concrete staircase 3 feet to the left later on.
Precisely. That is why the pre-check is so vital. Now, once that is approved, you move to step 2, which is documentation.
More paperwork.
Always more paperwork. This is where you prove you actually own the land, you show structural stability certificates, detailed electrical wiring diagrams. It's a full, comprehensive dossier.
And then step 3 is the actual build and the inspection.
Yes, you build it exactly according to that approved plan. Then the fire officers actually come out for a site inspection. They walk the factory floor. They check if the physical reality matches the blueprint. They physically test the alarms.
And the final step.
Step 4 is the final post-installation audit. If everything works, the alarms ring loud, the water flows at the right pressure, you finally get your NOC.
I saw a cost estimate in the notes that was pretty interesting. For a moderate hazard factory, say up to 18 meters high and maybe 500 square meters, the government fees might start around 1,000 rupees.
That's a pretty good baseline estimate. It definitely varies by state and by the exact size, but it shows that the official government fee itself isn't necessarily prohibitive.
Right.
The real cost is in the actual equipment, the heavy-duty pumps, the massive pipes, the specialized fire doors. The government fee is really just the admission ticket.
And it's not a forever pass, is it? You don't just frame the certificate, hang it on the lobby, and forget about it.
Definitely not. The validity depends entirely on the risk profile. A high-risk G3 factory might only get an NOC that's valid for a single year.
Wow, just 1 year.
Yeah, you have to prove you're safe every single year. Now, some states are reforming this a bit. The sources mentioned Kerala is now allowing up to 5 years for some of the lower risk categories, but generally it's a very strict recurring cycle.
Okay, so we've got the certificate.
Yeah.
But I want to really see what this looks like in practice. I want to move from the paperwork to the physical reality. Let's do a virtual walkthrough.
Okay, let's do it.
I want you to take the listener and me right onto a busy factory floor. We are the auditors now. What are we looking for first?
Imagine we walk in, it's loud, heavy machines are running, people are moving everywhere. The very first thing my eyes look for isn't actually the fire extinguisher, it's the way out. Checkpoint 1 is egress.
Getting out alive.
Exactly. The 2 exit rule is absolutely non-negotiable. There must be a minimum of 2 separate exits per floor.
And they can't just be right next to each other, right?
Right. They must be remote from each other. You cannot have 2 doors sitting side by side because if a fire blocks that specific corner of the room, everyone inside is trapped.
And I saw something in the notes about widths. Size really matters here.
It does. For factories, escape routes generally need to be at least 1.5 meters wide.
Why 1.5 meters specifically?
Because that allows 2 people to run side by side, or it allows 2 people to support an injured person between them while moving fast. If you have ramps, say, for moving goods, or maybe in a hospital setting, those need to be 2.4 meters or wider.
And here is a crucial detail that really stood out to me in the reading.
Yeah.
Absolutely no padlocked exits.
Never. History is unfortunately full of horrific tragedies caused by locked exits.
Right, like the Triangle Shirtwaist Factory fire.
Exactly. Business owners worry about theft, so they just chain the back door shut. An auditor will check that every single fire-resistant door, which needs a 1 to 2 hour rating, is completely unlockable from the inside without needing a key.
So anyone can just push it open.
Panic bars are great for this. You literally just crash into it, push, and it opens to the outside.
Okay, so we know how to get out. Now let's look at actually fighting the fire. Checkpoint 2, suppression.
Here, you are going to look for the 15-meter rule.
Which is what, exactly?
You should never be more than 15 meters away from a fire extinguisher.
Oh, wow. That's pretty close.
It is. Anywhere you stand on that factory floor, if you spot a fire, you shouldn't have to run a marathon to get help. Adrenaline spikes, mass confusion sets, and the tools you need have to be immediately within reach.
That is a really great rule of thumb.
Hmm.
And what about the heavy artillery we mentioned? The sprinklers.
Sprinklers are mandatory for areas over 300 square meters. But here is what a truly good auditor actually checks. The water source.
Because the sprinkler is useless without water.
Exactly. The sprinkler head is only as good as the tank feeding it. We check the underground or the overhead water tanks. The capacity is dictated by the building size, but more importantly, if the power goes out, is there a diesel pump ready to push that water?
Right, because fires very often cut the electricity to the building. If your pump is purely electric, you're just holding a dry, useless hose.
Exactly. Redundancy is the entire key to the system.
Moving on to checkpoint 3. The actual source of the fire. Electrical and hazardous materials.
This is where most industrial fires start. Auditors look closely for what we call electrical hygiene. Are there daisy-chained power strips?
Plugging a power strip into another power strip to get more outlets. The classic college dorm room setup.
Exactly. Acceptable in a dorm room, maybe?
Yep.
Fatal in a factory. Overloaded wiring literally heats up behind the drywall where you can't even see it. And as for chemicals, if you have flammable liquids, are they strictly stored away from any potential ignition sources?
I really liked the detail about rim guards in the sources.
Yes, on chemical storage racks. It's such a simple concept. It's basically just a metal lip on the edge of the shelf.
How did that help?
Imagine a forklift accidentally bumps the rack. Without a guard, a bottle of volatile chemical vibrates right off the edge, falls to the floor, shatters, and suddenly you have a massive chemical fire. With a rim guard, which is basically a 10-rupee piece of metal, the bottle just stays safely on the shelf.
It's such a small detail, but it entirely prevents a disaster.
It's all about eliminating the domino effect.
And what about for gases?
If you're in a high-risk area dealing with gas, a standard smoke detector just isn't enough. By the time there is actual smoke, it might already be way too late.
Because the gas has already filled the room.
Right. You need specialized flame or gas detectors that literally sniff out the leak before the spark even happens.
Fascinating. Finally, checkpoint 4. Infrastructure. The actual bones of the building.
We talked earlier about fire-resistant walls, but let's talk about the smoke. Smoke actually kills way more people than the flames do.
Really?
Oh, absolutely. Asphyxiation. So, I'm looking at the lift shafts and the stairwells. Are they pressurized? Or do they at least have vents at the very top?
This is the chimney effect, right?
Exactly. Hot smoke always rises. If your concrete stairwell is sealed tight at the top, the smoke just fills it up from the top down, exactly like filling a bottle with water.
And then the people running down the stairs can't breathe.
Right. The code requires vents of at least 0.2 square meters at the top of these shafts.
Yeah.
It basically lets the building exhale the poison so that people can actually breathe on the lower floors as they escape.
It's incredible. You start to realize that the building isn't just a static box. It's a complex machine specifically designed to breathe and direct heat away from the people inside.
Precisely. It is a machine designed for survival.
But in these scenarios, you can have the absolute best 2-hour rated walls, the fanciest gas detectors, and the perfect rim guards on every shelf. But if the people inside don't know what to do, it's pretty much useless.
That brings us to the final and perhaps the most variable piece of this entire puzzle, the human factor and maintenance.
The audit actually checks for soft skills too, doesn't it?
It does. It explicitly asks, are there regular evacuation drills? Is there a documented staff training record? You can't just buy a bright red first aid kit and leave it locked in a manager's cupboard.
People need to actually know where it is.
And more importantly, does the floor staff have the muscle memory for exactly what to do when that alarm rings?
And then there's maintenance. I think this is where a lot of places might naturally slip up over time.
Because equipment expires. An extinguisher isn't a rock. It constantly loses pressure over time. The active chemical powder inside can settle at the bottom. IS 2190 mandates that they be fully pressurized and strictly within their expiration date.
And the big pumps.
Fire pumps need to be run regularly just to make sure they haven't seized up. Hoses need to be actively pressure tested to ensure they don't just burst when you finally turn the water on after 3 years.
And the NOC renewal process basically forces this to happen, right?
Yeah.
Because if you want that valid certificate again next year, you have to physically show them the maintenance logs.
Exactly. It forces the management to look at the little paper tag on the extinguisher and say, oh, wait, date expired last month. It imposes a steady rhythm of safety that constantly fights against normal entropy.
So what does this all mean for us? We've gone all the way from the Factories Act of 1948 to the BIS technical codes, through the pre-construction blueprint phase onto the actual factory floor and into the staff training room.
When you zoom out and look at it all, the NOC isn't just a piece of paper. It is a massive, interconnected system of checks and balances, structural, mechanical, and human.
And for the business owner out there listening to this, why should they care beyond just, well, the law says so?
Well, beyond the very obvious moral duty to not let your employees be in mortal danger, there's a very hard business case for this.
Like insurance?
Yes. Insurers very often offer significant premium discounts for valid, up-to-date NOCs. It naturally lowers your premium because you are statistically a much lower risk to them. And above all, it guarantees business continuity.
That makes total sense.
Think about it this way. A small fire in a well-prepared factory where the automatic sprinklers work instantly and the staff knows exactly what to do is just an incident. You clean up the water, maybe you lose a single day of production. A small fire in a completely non-compliant factory is a catastrophe. It's a total loss of the building. It's bankruptcy. It is criminal legal action.
That is a very powerful distinction to make. An incident versus a total bankruptcy.
And if we really want to connect this to the bigger picture today, I want to leave you with a thought on passive versus active safety.
Go on, let's hear it.
We so often focus on the active stuff, the bright red trucks, the loud sirens, the brave firefighters sliding down poles and rushing in. That's cinematic, that's active safety.
It's what we see in the movies.
Right. But the real heroes are the silent, passive elements we discussed today.
The boring stuff.
The boring stuff. The concrete corridor that is exactly 1.5 meters wide so you don't get crushed in a panic. The heavy door that silently holds back a roaring fire for 2 hours. The little vent that automatically opens at the top of the lift shaft.
Wow.
These things save lives long before the fire alarm even rings. They patiently buy you the time to survive.
That is a genuinely fascinating way to look at the world around us. The blank wall saving your life is just as heroic as the firefighter.
Absolutely. The engineering is the silent guardian of the whole system.
Well, I am certainly going to look at the illuminated exit signs and the specific width of the hallway a little differently when I walk out of the studio today.
As you should. Never take the passive safety for granted.
That is going to do it for this deep dive into the complex world of fire NOCs and safety audits. We hope we've sparked some interest safely, of course, in the hidden engineering that keeps you safe every single day. Thanks for listening.
Stay safe, everyone.